Mo. Hello everyone, it's January, July, June. Jesus. June 15th. Alright, let's do this. Another hard problem. Hopefully this time we don't need to read the hints. Given a sorted integer array and an integer n, add patch elements to the array such that any number in the range 1 to n inclusive can be formed by the sum of some elements in the array. Return the minimum number of patches required. Hold on, let me read it one more time. It's sorted, okay? And n, add or patch elements to the array such that any number in the range from 1 to n inclusive can be formed by the sum of some elements in the array. Alright, so the first one, so nums are in ascending order. Num's length is 1000. And there can be many combinations. And each number can only be used once, I suppose. Yeah, most likely each number can only be used once. So if just 1, 3, we have 1, 3, and 4. So we need 2. We need 5, so we just need a 2. Interesting. 1, 5, 10. And a 1, 2, 2. 1, 2, 3, 4. What do you think? Well, let's see. 1, 3. We have 1, 2, 3, 4, 5, 6, right? How do you tell if it can be formed by any, each number used them once, which is okay, right? Which is okay. We can say check 1, like 1 has to be in it, okay? And check 2, you can put another 1, right? That can make 2 as well. 1000. Well, as a combination, I think if you take all combinations of different types, it's 2 to the n. That's way too big. So that is not a solution for this. And n goes all the way to the really large. N goes really large. I don't like this example. Let's try this one. 1, 5, and 10. Okay, so we need to go 1 to 20. So 1 has it. 2 doesn't have. So for 2, we can say we put a 1 or we put a 2. We don't know, right? At this point, we do not know. And yeah, let's say if it doesn't exist, we just like greedy it. We just say, yeah, we just put 2 in it. Okay, so we put 2 in it. Okay, we put 2. Oh, hold on, but it also says it's sorted, right? It's a sorted integer array. I haven't used that piece of information yet. What does sorted mean? Right? What does sorted mean? Maybe we can say is, up to a certain number, how many different values we can make. So up to here we can make 1, and we need to make 2. We don't have, so I can put a 2. Okay, let's say I put a 2 in here. All right, and because I have a 2, I have 1 and 2, right? I have 1 and 2, and the next one is 3. But then we have to iterate through every single one in this range if n is really big. That doesn't seem to be, because 2 to the 31 is 9 digits, right? If you want to do it this way, 9 digits doesn't seem like, right? Does not seem like. Huh. Interesting. Well, you enjoy. Welcome. Alright, let me see. Yeah, we put a 2, then we can say, okay, if I have a 2, then I have 3. Right, I have a 3, but I don't have a 3, so we don't have 4. Right, we're missing 4. So I need 4, right? In this case, I need 4. Okay, then we have 5. We need 6. Since we have 5, then we have 6. Then we have 7. 7. Yeah, we have 1, 2, 4, 5. And then we say, can we form 7? How do we check? I mean, for each one, we have to check. It doesn't have 6, but have 5. So 7 is good. 8. Nah, this doesn't feel right. Like, how do you check for 8? Maybe what we can do is all different. So up until here, we can form 1. Up until here, we can form 1, 2, and 3. So up in here, we can form whatever they have plus this, right? So we have 1, 2, 3, and then add it 4 by itself, 5, 6, 7, right? Up into here, we can keep adding 1, 2, 3, 4, 5, 6, 7, and we put 5. So 6, 7, 8, 9, 10, 11, 12, right? Is that right? Yeah, we can have all the way to 12. And then the next one is a 10. So because all the way to here, I can form all of this. So with 10, yeah, they can form everything. So with 10, basically, we just go from 13, 14, 15, 16, 17, 18, 19, 20. I feel like I'm getting closer, okay? I think I'm getting closer. Basically, what we need is to go one by one, right? One by one, and we'll make sure that up until the current one under consideration, we can always form all the numbers. That's awesome, right? All the numbers. And then when we add a new one, right? When we add a new one, we can form all the way towards, like when we add 10, we can form all the way towards 22, right? Because the previous is just duplicate, it doesn't really matter. But what it matters is from the 13, 14 all the way to 22, right? Whatever the next value is, we can just extend. This is a very interesting idea. So 1 is just 1. 2, we don't have, right? So we have to do 1, we move forward. So now pointer 3, right? But we are currently looking at 2, and we don't have 2, right? We don't have 2, so we say we add 2, and when we add 2, the ones we can form all the way extended to 3, right? We can form all the way extended to 3. The next one is 3, we can form all the way extended to 6, right? Here, 1, 5, 10. Okay, 1, 5, 10. We start with 1. Next is 5. It's bigger, right? It's bigger than what we had, because we're looking for 2, right? We're looking for 2, but the current is bigger, so 2 must be added. So we add 2. Okay, and once we add 2, so well plus 1, right? We add 2, and now we can add in 3. Next, we'll look for 4, right? Because we can extend to 3, and we need 4, but current is bigger, so we have to add 4. So now we add 2 values. Now we can all the way go to 7, right? Now 5 is covered, so I can extend all the way to 12, right? 10 is covered, so I can extend all the way to 22, and then that is what we want. Next one, 1, 2, 2. We start with 1, move forward. It's a 2, and we're looking for 2, and it is covered because it's within it's actually what would we say, because this is all the way to 1, right? So the current one is bigger than this, so it doesn't cover. So when you take a look at current one, and a current one says a certain number, and then we say but why I have to add more? Because we can say extend. Yeah, because if this is bigger, right? If this is bigger than this, right? Because it's 1 towards something. And if the something is bigger, then we'll cover everything. But if there's a gap, then we cannot cover. There are things that's in between we cannot cover. So in here, we're looking for 2, and there's no gap, right? This is a 2. So we can just say, so basically if the current is smaller, that is not possible, right? This one's not going to be smaller than what we have, because what we are doing is 1 by 1, right? We go here 1 by 1, but if it's smaller, then we just, we keep adding, right? We keep adding. If this is smaller than what we have, we just keep adding, or smaller equal to this, then we gap. We have to look for gap, right? So if there's no gap, then we can keep going. If there is a gap, we should stop. So yeah, we keep going, right? We from the start, we keep going until we find the first gap, right? And then we take a look at this, right? If it's okay. If it's, what we say is if hold on. Again. We're looking for 2, right? And Are we looking for what are we looking for? We're trying to extend all the way to n, right? We're trying to extend all the way to n. Don't say we're looking for 2, right? That's no, don't say we're looking for 2. We just say we are trying to extend to n, and at the first position we can extend to 1, right? And the next one, if there is a gap, then we have to fill somebody in, right? We have to fill somebody in. If there's no gap, I just go, this one will give us to 3. And this is bigger than this, so this will give us to 5. So we go through this, everything, and try to see if we can fit. If it's bigger or equal to n, then we're good. If it's not, we just keep adding more values to the end. Okay? Let's give us a shot. It might work. Okay, let's see. All right. So here is the idea. Of course we have a rest equal to 0, and we have a reach. Okay, reach is 1. Oh, actually reach we don't know. We start with reach with 0, right? And I have to go through n one by one, right? One by one. And we need a pre, because we need to know if there's any gap, right? And the gap is considered, no, by the reach, right? By the reach. So I can say for int, let's try this, int n to num. I cannot use n. Ugh, num. Okay. Hold a second. Oh, you're really making this difficult. Alright, a cat is being difficult. Okay, so we go through every number, right? And then we want to see if there's any gap. Let's say, if the current number and the reach, let's do a good scenario, right? Good scenario is there's no gap, which means either, right, there's no gap is reach is 1 smaller than num, right? So we say if num minus reach is smaller or equal to 1, okay? Which means either the current number is smaller than the reach, or the number is only 1 bigger than the reach. So this is a good scenario, right? This is a good scenario. We say no gap. And in that case, we can say reach plus equal to num, right? We can keep moving on, right? Else, then this is where we have a gap. And when we have a gap, what we need to do is, oh, we cannot do it this way. We cannot do it this way. We have to do it this way, because I do not want to progress the pointer if that happens, right? Yeah, so we do that, and there's no num. We can do num. We can say int num is num's I, right? We get a num back. This is still good. Plus equal to num and I plus plus, right? In this case, we're just moving on. In this case, we have a gap. Then we say reach or plus equal to, because we need to add, right? And then we need to fill the gap, so it's a reach plus 1, right? Because there's a gap, so we need to put the smallest, right, in this gap in it. So we put that in, and I doesn't change, because we have to go back. We try it again, right? Want to try it again. Okay. Oh, and the rest plus because that we added a 1. Okay, I don't want to use this variable, so what I'm gonna do is I'll just do that, and I'll do that. I'll delete this. Right, and then we'll go this all the way to the end. So when we go to the end, we exhaust all the nums. Then we need to check if the reach has. In fact, we can check right here, right? So we'll do this if we can say if reach is larger equal to n, then we just return res. Done. We don't have to go to the end. But if we have to go to the end, that means we have not, right? That means at this point we have not. This is Python. No, my bad. This is not Python. This is Java. Damn. This is Java. Not my favorite language for sure, but just for practicing purpose. Where am I? So if at the end reach has not reached n, so we have to keep going forward, right? I have to keep going forward. This is interesting. All right, this is interesting. I think I'm gonna change how I do the loop. I definitely gonna change how I do the loop. What I'm gonna do is while reach is smaller than n, okay? Then I don't have to do this, I don't have to do this, and I will just return res here. Before I say this, I will always check I is smaller than nums.length, and right, I'll do this check, and I will do this blah blah. Once we end the nums, we exhaust everything in nums, then we don't go through this, so we always just add this, and then we keep just going on. Length cannot be resolved because I have a typo. All right, let's try this. Let's see how it goes. Are we good? Looks like we're good. Okay, let's be confident and then do this. This is LeetCode 330. All right. So the idea is find the maximum reach, right? All the numbers from nums I towards the current can get, right? If this max reach overlaps, right, with nums I plus 1, then we can extend the reach by doing reach plus nums I plus 1, right? Otherwise, we have a gap and need to fill in some values. Now greedily, right? Greedily, we will only put in. It's actually not greedily. That's the only way. You have to put in the value that has no gap. Right? The value to put in, right? To put in must not create a gap. Create a gap from the reach, right? Thus, the only one we can use is reach plus 1, right? Reach plus 1, and this will extend the reach to reach plus 1, right? Then we can check with nums I plus 1 again, right? We can check with it again. Yes, I think C++ was in the second semester of my undergrad. I did C++. The first semester is C, which was quite fun. C was always quite fun. And the second semester was C++, and it was a complete garbage. Not like the language is garbage. I mean, the language is way too complicated for me to even give it any judgment. But I didn't do very well. It's just complicated. It's so convoluted. You know, the left hand side, right hand side, all different ways just to assign a value, and I don't even remember all that. And the documentation, it keeps changing. It took a long time for me to set up my environment to do it. Uh, what I think is, I did what I need to pass the class, but then I pretty much said I don't want to touch the language again. And then you heard that Java is very popular, good to find a job. So just keep practicing Java. But my go-to choice is always Python. This is what I think. Python is the universal glue language, right? There will be stuff written in a much faster language, but ultimately, if you want to call those, Python is your glue language. You glue them together, and Python's getting faster too. Wait, where am I? Then we can check with again, right? And then we keep going. Right? We keep going until the reach exceeds n. What do I think is the runtime? Honestly, I have no idea, because the reach keeps moving forward. It may go really fast. It may go. Actually, that's a good question. I don't know. No idea. We might have to OON, right? The length of nums we have to go through. But after we go through this, maybe like a log n. We'll call it ON log n. I don't know. I'm not putting any time complexity. Well, we'll figure out. Come on, we'll figure out. We'll figure out time complexity. All right, let's see if this one's correct. Pretty much is, because last time I did it, a one shot. Oh my god. That must be something is overflowing. Damn. See, that's this type of language, you do Python a lot, that handles all this for you, and then now you have to do this. Holy crap. Okay, so most likely we overflow. So the reach, we have to do long. Okay, and we have to do long here as well. Yeah. Do we have to do this long? Reach is already long, so I just need to make this long. Yep, I think I saw it by myself last time. We can read how did I do it last time. There we go, right? It's just overflow. There we go. Not bad. Not bad at all. Wait, hold on, we need to copy this again. And then we do this. Alright, it will be interesting to see my solution. That was 2-3 years ago. Yep, exactly. I think it's almost exactly the same, right? You see this? You see this? Almost exactly the same. 2 year, 9 months away. 146 test cases. Let's see if any change in the test case. Nope, no change. Just same old problem. Stephen Pockman. That was so long time ago. Dude was an absolute legend. Yeah. I wonder if he's still doing this. 14 days ago, he is still doing this. I mean, not a lot, but he's still doing this. Occasionally. Oh, has a big gap. Well, I wish him the best. I hope he continue to do this. What is he doing these days? Nah, I think it's the same. It's the same stuff. Last time I checked, he was into the juggling. I'm not sure if he's still doing juggling now. No, last modified. That was him. Now he must be doing something different. If you're talking about some really smart dude, now this is a very smart dude. Okay, so we're good. Good. And we're gonna move on. I think I have capacity to at least try one more. Okay, let's try one more. Count of interesting subarrays. You're given a zero-indexed integer array, an integer modulo, and integer k. Your task is to find the count of subarrays that are interesting. A subarray is interesting if the following condition holds. Let count be the number of indices I in the range such that nums I modulo this one is equal to k. Then count modulo, huh? Oh, let me read it one more time. Let count be the number of indices in the range. Number of indices in the range, that's just r minus l plus 1. Such that nums I, so nums I and the count have the same modulo. Right? I think it's written as this. I may be wrong. I think it's written as nums I, this count mod modulo, right? I think that's the mathematic expression for this. So these two have the same modulo when they mod this one, right? That's return integer denoting the count of, so how many integer, how many interesting, a subarray. Okay, let's check the thing. 3 to 4. In this example, interesting integer subarray. Oh, that is interesting. Yeah, L and R can be the same, right? Which is 3, because 3. Okay, so when we do that, when L R, right? L is 0, R is 0, and then we'll have be the number of indices such that number of indices I such that, okay, I still don't understand this one. Let me say one more time. Like count be the number of indices I in the range such that nums I equal to k. Then count modulo this is equal to k. No. I think the count is the number of I, number of this, such that they all have the same modulo. So in this case, what's the count? Well, count is 0 because you only have 1. Well, actually, no, count is 1. My bad. Count is 1, right? And actually, you don't know count is 1. We have I, which is 3. 3 mod 2 is 1, and the count is 1. Okay. Hence, count is 1 modulo. Okay. The subarray 0 to 1. We have 3, 2. There's only one index. So, we need to find who within this modulo 2 is equal to 1. So 3 is the only one, right? So count become 1, right? There's only one index satisfied equal to, hence count is 1, and 1 modulo, yes, that is true. Subarray 0 to 2, there's only one index. So the count modulo this equal to this, and then this one can be shown there are no other interesting subarrays. Okay, so basically we have a subarray, and okay, so no. So this is the thing. We need to find a subarray such that there are k numbers. Yeah, this actually sounds better, right? There are k. Actually, not true. Not true. Right? It's just a modulo. Yeah, so the number of the number of values who modulo equal to k, number of values modulo to k, that number, that count modulo this is also equal to k. Gotcha. Okay. So this 3196. Okay. So the first thing we can do is try to find who modulo 3 equal to k. Whole modulo, so this is good, this is bad, this is good, and this is good, right? So we turn the array into this. Then what we just need to see how many subarrays, right, that has the count of these modulo 3 equal to 0. So which means we want the count of these check marks to be either 0 or 3k, right? We need to be 3k. So 0, 3, 6. And 0, we have this one. 3, we have this one. So the answer is 2. Got it. Okay. I think I know what this one is looking for. I just understood the problem. Now I need to figure out. I think this is the right step, right? We get the ones that fit the bill. Then we just need to know, how many subarrays contain, we can say actually modulo, right? Modulo times, I don't say k, let's say times p, right? Times p plus k. We need to have that count of the thing, okay? So we start with p equals 0, right? So we say p equals 0, so it's actually k. So we need to find how many that contains k. So we have the first, and then we go, oh, that's more like, that's more like the sliding window, right? Yeah, it's like a sliding window, because you have to contain all of them. So you find how many these are, right? You find how many these are and say I need k number of them. Then you check if there exists k number. If there exists, and then you can actually very quickly compute how many there are. And then you do p equal to 1, p equal to 2, and then you try to see. Yeah, there gotta be I think there will be a formula for this. We'll figure it out later. Yeah, we can do that. And yeah, that's about it, right? That's all there is to it. Which one is better, C++ or Python? Depending on what you want to do. You want to do low level. I know games. I think in the old time games, or a lot of games are written in C++. Nowadays I think it's different, but low level stuff C++. But I don't know. C++ is very, it's old. It's widely used, so it's definitely you can have a lot of job opportunities. There are new fancier language nowadays. You have Rust, which also can handle a lot of low level stuff, and then you have C, for sure, right? Python to me is one of those must-have language. You just have to know. You don't have to be like an expert. You just need to know how it's done, right? Like JavaScript, you need to know JavaScript, Python, probably Go, Java. Like all of these are very fundamental that you have to do. Nowadays, I think Python is more data science. Yeah, data science is just Python. Easy to write, but very tough to maintain. Yeah, I've done some work in maintaining Python, like app in Python. One script, 2,000 lines, that type of stuff. It's a hell to maintain, and there's no typing. There's no typing, so things moving around, you don't know where they are. Bad, definitely bad. Yeah, Python without typing is, yeah, but it's good for proof of concept. If you want to just get something set up to run. Scripting, definitely scripting. I like Python for scripting. Much easier, much more intuitive compared to, let's say, Bash, right? Yeah, I think we have it, right? I think we have it. And now we need to, and then when it's 0, okay, this is the difficult part. 0. Well, basically we have the remaining, right? All the crosses remaining, and oh, isn't that just 2 to the power, right? Isn't that just 2 to the power? That is interesting. I think it is just 2 to the power, because in this case it's 4. Wait, is it 2 to the power? No, it's not 2 to the power, because it has to be still. Oh, no, you cannot. You have to find them out. You have to locate them specifically, right? So if I have something like this, right, you cannot just get them out. It's like in this island and in this island, right? In fact, let's do this right now. We can create one to form the situation, and yeah, we just do this, right? 0 or the 3, exactly. So we'll have 3, we have 1, because we have these 3, and 0, we have this one. This one will contribute 1. This one will contribute 2 plus 1, right, with 3. So this shall be, answer will be 5. Okay, let's try this. The answer shall be 5. We can do, so 3, 1, 9, easy, 2, 5, and a 6. The answer shall be 5. Come on, give me 5. Yep, that's it. Okay, I think we can do this. We did this is 2845, right? 2845. I think we can do this. All right. So, do we want to modify on it? No, I don't want. So I can just say, that's a true or false array, right? That's just a true or false array. Okay, so what we need to do is good and bad, right? Good and bad. So we can say good and bad, right? And these are numbers num modulo equal to k. These are not num modulo not equal to k. Okay, and this is an array of array, because we have to, well, it depends what k is, right? It depends what k is, but we'll do it still. I think it's fine, right? I think it's fine. If a k is not equal to 0, then we don't have to worry about this bad array. Okay, for n in, but do we even need a good array, right? We don't. Why do we need a good array? All we need is the count of good. We need a bad, right? This is just count, right? Count is enough. Bad, depends, right? Bad, it depends, but I might as well just include it. Tough call. If n mod modulo is equal to k, good plus equal 1, else, see, now this is the thing, else You need to put in bad. I mean, all we need is count as well. Let me change the name. This is count good, right? This is count good. This is count bad. But this is an array because we need consecutive. This each element is the count of consecutive bads. But how do you know it's a consecutive? We can do modulo twice, right? We can do modulo twice. This is good, and actually we can have because I need to know the do I need to know the previous value? Dude. Okay, else what do we say? We say so the current is not, and if the previous is, how do you know the previous? Yeah, you don't know the previous, so we have to have I, right? And we need to enumerate, right? Oof. And then we'll say elif, okay, elif I is equal to 0, or nums I minus 1 modulo is not equal to k, right? In this case, then you're the start. So I say count bad dot append 1, right? Then you are the start. You are starting. This is the start of. Hold a second. We don't have this. Is count good. It is the start of the new bad, right? This is the start of the new bad. Else, I is not equal to 0, and the previous one also modulo not equal to k, right? So in that case, then you will be consecutive. So we say count bad minus 1 plus equal to 1. All right, once we've done this, we have everything, and then we basically said while. So the p is equal to, we start from 0, right? While modulo times p plus k, this is the length, is smaller or equal to len nums, right? If it's smaller equal, actually no, smaller equal to not len nums, my bad, smaller equal to count good, right? If it's smaller equal to count good, then we have a result, right? Count good, then we can. Did you open the bedroom window? No, I did not. I'll do it right now. All right, let's finish this up. Actually, p should not start from 0. I mean, p can start from 0. It's k, right? It's k. So if k is 0, that's if k is 0, then we'll have 0, right? And I need to know what's the current length. And if the current length is 0, yeah, hold on. Current length is equal to modulo times p plus k. We say current length is this. If current length is equal to 0, then, well, rest plus equal, then we have to do something here. Okay, we'll deal with this later. Else, if the current length is not, then we'll say rest plus equal to count good. So now it's the thing. If I have a length of 5 and my current length is 1, then it's just 5, right? If my count is 5, my length is 2, then the number of subarrays is 4, right? And if my length is 5 and it is a 5, then it's 1. So it's almost like count minus current length plus 1. Does that make sense? Does that make sense, right? Yeah, it's basically this. If I have 1, 2, 3, 4, 5, and I want current length is equal to 3, then we have 1, 2, 3, which is 5 minus 3 plus 1. Yeah, that makes sense to me. So that's good. Now keep going. After we've done this, we will, you know what? What do we here? If current length is equal, so we don't have to do this if statement at every single thing, right? So yeah, I say if this is equal to 0, then rest are equal to whatever, right? And we don't have to do this. And then current length, well, plus equal to modulo. Then we'll do this. Right? And then after that, current plus equal to modulo. I don't know. Does this look good to you? Or we put this one inside? It's alright. It's alright. Okay. In fact, I can just say k equal to 0. Then I don't even need p. Why you need p? You don't need p, right? And we don't need this. Current length can be put in here, and it will just be this modulo plus k, right? So we don't need this either. So now we just need to figure out how to count this. So basically this is going to be a sum, right? For the count bad. So for C in count bad. Now, this is interesting because k is equal to 0 and all of these are bad, which means they do not modulo equal to k. So any subarray will work, right? Any subarray. So now the question is, given, right? Given this, how many subarrays are there in this? So that should be just 5 plus 4 plus 3 plus 2 plus 1. Right, 5, 4, 3, 2, 1. So it will be a formula, which is count times count plus 1, because you start from 1 all the way to count, right? Divided by 2. That makes sense? If I have 3, that's 3 times 4 divided by 2. Yeah, wait, hold on. 1, 2, 3, 4, 5, 6, yeah. Okay, so, and then at the end, we'll return rest. Okay, we'll give this a shot. Let's try this one first. Huh, what happened? It just keeps pending. Now what I realized, I don't even need this, right? I don't even need this count bad. I would probably have to. I don't even need this count bad. So count good is this, and this is not count bad. I can just say number of subarrays. Count subarray bad, right? The number of subarrays that do not contain any num modulo equal to, okay, right, and this is going to be 0 as well. Oh no, we still need to count. We still need to count. Count bad. Count of num. Count of consecutive num modulo not equal to k. Count subarray bad. Count of number of subarrays whose numbers modulo not equal to k. Alright, so now this is good. This is, we need to append, which means it's a new one. So I will do, this is count bad equal to 1. Actually, before that, it should be count subarray bad plus equal to count bad times count bad plus 1 divided by 2, right? Because the previous count bad, we go to the count subarray bad and then reset this, and this one will just be count bad plus equal 1. So if now we can say this is equal to count subarray bad if k is equal to 0, else 0. So now we don't need to do this. Then there's no arrays. Okay. Let's try this. Yeah, it's good, but let's use these. Let's do this. Run one more time. Ooh. Okay, that's more likely the issue. Okay. It's alright, just debug. Let's print count good, count bad, and count subarray bad. So count good is 1, count bad is 2, and count subarray bad. Okay, that makes sense. We have to do that one more time. So res is 0, right? Res is 0, and modulo oh, I see. We have to start with k. Okay, yeah. We have to start with k. And then we shall say if current length is equal to 0, rest equal to count subarray bad. Okay, else rest equal to this, and then okay, let's try it again. Output 1. Okay, 1 to 3 is good. Oh, that is correct. Ah, Lord. This is wow, we're getting into some very thick, tricky area. That's right. I'm including this, but I have to take into consideration. Oh. All right, a little bit overconfident on that one. Yeah. All right, we need sliding window on this, unfortunately. Yeah, I have to reconsider this. I probably have the sliding window. All right, it's already over an hour. I'm gonna cut it today. Yeah, this needs sliding window. Not hard. We already have the gist. It's just yeah, I oversimplified some stuff. It's all right. It's all right. We'll continue to do this tomorrow. All right, I'll see you guys tomorrow. Adios.